Hello students, welcome to the lessons Materials, Metals and Non-Metals, Part 4. In the earlier part of this lesson, we have learned how metals and non-metals react with dilute acids. In this lesson, we will learn one more interesting chemical reaction of metals and applications of non-metals in our daily life. Displacement reactions. To understand this reaction, look at the following general equation. Bc is a compound formed from a metal B and a non-metal C. The metal A replaces metal B from the compound Bc to form a new compound AC. This type of reaction is known as displacement reaction. In a displacement reaction, a metal replaces another metal from a compound. Looking at the above equation, can we also say that metal B displaces metal A from the compound AC and give the compound BC back? If not, why? It is something like in a tug of war, a strong person wins over weak. That is, whenever there is a competition, the strong person wins. A similar situation exists here also. That is, the more reactive element displaces the less reactive element. Such reactions are called displacement reactions. A displacement reaction is a chemical change in which one element displaces another element from a compound. Let us perform some activities to understand displacement reactions.
To add copper turnings, and to another beaker I am going to add iron nail. Now let us wait for 60 minutes and let us observe if there is a change is there or not. Now after 60 minutes we can observe that there is no change in the solution. So which confirms that there is no reaction between copper and zinc sulfate and iron and zinc sulfate. Students, here we have the last set of reaction. Here I have with me ferrous sulfate solution which I have taken into the beaker. Now to that I am going to add copper turnings. Again we will wait for 60 minutes. Students, we are observing after 60 minutes, but there is no reaction has taken place in this solution. So which confirms that the iron sulfate solution is not reacting with copper turnings. The metal which is more reactive than the other metal which is present in the same solution will displaces the lower reactive metals, and these all set of reactions are called displacement reactions.
From these experiments, we observed one metal replaces another metal from a compound. We also learned some metals are incapable of replacing other metals. The fact is, a more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace a more reactive metal. Then tell me, how to identify which is more reactive and which is less reactive metal? Can we also arrange the metals in the order of their reactivity? Based on the extent of reactivity of elements, scientists have arranged the elements in a series called reactivity series. In a reactivity series, the most reactive element is placed at the top and least reactive element at the bottom. We see that in this series, potassium is placed at the top, means it is the most reactive element. Silver, gold and platinum are at the bottom, indicating that these are least reactive elements. Now, let us verify this series with our experimental results. Beaker A. Zinc granule added to copper sulfate solution. Observation. Zinc granule becomes dark color due to the deposition of copper on it, and solution turns blue to colorless due to the formation of zinc sulfate solution. Inference. Zinc is more reactive metal than copper. Zinc displaces copper from copper sulfate solution, and zinc 2+ ions goes into the solution to form zinc sulfate solution. B. Iron nail added to copper sulfate solution. Observation. A brown coating of copper is coated on the surface of iron, and the color of the copper sulfate solution changes from blue to light green. Inference. Iron is more reactive than copper, as iron displaces copper from its solution and iron goes into the solution as Fe2+ ions to form ferrous sulfate solution. C. Copper turnings added to zinc sulfate solution. Observation. No change. Inference. Copper is less reactive than zinc, so copper cannot displace a zinc from the zinc sulfate solution. D. Copper turnings added to iron sulfate solution. Observation, no change. Inference, copper is less reactive metal than iron. Copper cannot replace the iron from iron sulfate solution. F. Iron nail added to zinc sulfate solution. Observation, no change. Inference, iron is less reactive metal than zinc. Hence, iron will not displace zinc from its salt solution. So far, we have learned about the chemical properties of metals and nonmetals. We also learned about the uses of metals in our earlier part of this lesson. Are only metals useful to us? No. In fact, the air we breathe contains oxygen and nitrogen. Water is made up of oxygen and hydrogen atom. These are examples of nonmetals. That means nonmetals also useful to us. Carbon is the basis for life. Carbon is found mainly in living things in the form of a complex organic molecule. About 97% of the human body mainly consists of only 6 elements: carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur. Carbon dioxide is essential for green plants to carry out photosynthesis. Other applications of carbon include activated charcoal, which is used for purification and filtration. It is also found in respirators and kitchen extractor hoods. Carbon fiber is finding many uses as a very strong yet a lightweight material. It is used in making lightweight yet strong tennis rackets, fishing rods, rockets and aeroplanes. Graphite used in pencil lead and found immense applications as electrodes. Diamond is used for making jewelry, employed as a cutting tool, are all allotropes of carbon. Nonmetals like nitrogen, phosphorus constitute a prominent component of fertilizers. These are applied in agricultural field, enhance the growth of plants and crop yield. Sulfur is commercially used in the production of sulfuric acid, sulfates, several sulfur containing compounds and in industrial processes. Sulfur improves the efficiency of other essential plant nutrients, particularly nitrogen and phosphorus. Sulfur is also used in matches, insecticides, fungicides, even in fertilizer in the form of calcium sulfate. Sulfur and phosphorus are used in crackers. Chlorine is used in the water purification. Chlorine is also a powerful disinfectant. It is an agent to purify water for drinking purpose and helps to keep swimming pool clean by killing bacteria and microorganisms. Chlorine is also used as a bleaching agent which helps in removing stains or color from various materials. Iodine is used in the medical field as iodine solution. It is purple in color, applied on wounds as antiseptic. Hydrogen and nitrogen is used in the synthesis of ammonia and in the manufacture of nitric acid and nitrogenous fertilizers. Hydrogen is used in the manufacture of vanaspati fat, several organic compounds, hydrogen chloride, metal hydrides and so on. It is also an efficient rocket fuel. Noble gases such as argon, xenon are used in all kind of colorful displays and signs like advertisement logos and signboards. Dear students, In this session, we are enlightened with a lot of information about metals and non-metals. It is time to recapitulate. Metal displacement reactions are those in which more reactive metal displaces less reactive metal from their compounds in aqueous solution. Both metals and non-metals not only create and sustain life, but also contribute to the quality of life. Here are some questions for you to ponder about. If the following arrangements of flowers represents a displacement reaction, then which flowers represents metals? Which flower represents more reactive metal? Among the pair, identify which shows displacement reaction. Silver nitrate solution plus copper metal, copper nitrate solution plus silver metal. Among these two pairs, copper is more reactive than silver. Hence, copper displaces silver from silver nitrate solution. So, the correct answer is option 1, that is silver nitrate solution plus copper metals shows displacement reaction. Prepare index card for 4 metals and 4 non-metals. The card should have information like the name of the metal or non-metals, its physical properties, chemical properties and its uses. For your understanding, one such card is prepared here. To make an index card, we need to take square cutout of cardboard sheet. On a front sheet of index card, paste the picture of the metal or non-metal you want to select. On the back side, write the information related to the respective metal or the non-metal such as physical properties, chemical properties, uses, etc. Construct a concept map based on the information provided in this chapter, metals and non-metals. Dear students, I hope you enjoyed and understood the reactions of metal and non-metals and applications of non-metals in this lesson. Still more information about the metals and non-metals we will study in our higher classes. Thank you.